Okay, let's find the limit as x goes to 1 from the right of the natural log of x times tangent pi x over 2. This is not the right form to use L'Hopital's rule on. So you've got one function, natural log of x, times another function, tangent pi x divided by 2. And you can go ahead and directly substitute in 1 into the natural log of x. You get 0. So looking at the indeterminate form, before we use L'Hopital's rule, we have to see if it's the right indeterminate form so that L'Hopital's rule applies. So we get 0 times, okay, the tangent of pi times x divided by 2, okay, as x approaches 1 from the right, the input here is going to be approaching pi over 2 from the right. And if you think about the graph, it's going to go down to negative infinity. And if you don't know that, you can always look at a graph. Tangent pi x divided by 2. We'll graph it on a standard screen. Zoom number 6 goes from negative 10 to 10 on both axes. The window does. And if x is approaching, well, 1 from the right, then we're looking at this branch. And okay, if x is approaching, there's 1 right there. If x is approaching 1 from the right, oh, the graph is going down to negative infinity. So that's how I got that negative infinity right there. That's not the right form to apply L'Hopital's rule. So let's rewrite this thing. The limit as x approaches 1 from the right, I'm going to put the tangent on the bottom. And the way I'm going to do that, I'm going to rewrite this as the natural log of x. And then on the bottom, that'll become 1 over tangent pi x divided by 2. But that's the same as cotangent pi times x divided by 2. So multiplying by tangent is the same as dividing by cotangent, right? So that's how I got that. And now, if you think about it, we still have the natural log of x on top. And as x approaches 1 from the right, that limit is still 0. And then if you think about the cotangent of pi times x over 2, well, that limit has to be 0 as well. If the limit of the tangent was negative infinity. If you have trouble seeing that, you could always go to y equals on your calculator. Make it 1 divided by tangent, right? That's cotangent. And then you could see it on the graph that way. And you can see that as it goes through 1, the output's 0. So the limit as x approaches 1 from the right has got to be 0. So you do get the right indeterminate form there, and you can apply L'Hopital's rule, big old check mark. Okay, so L'Hopital's rule. So you can put an h above the equal sign to indicate you're applying L'Hopital's rule. Take the limit as x goes to 1 from the right. Okay, take the derivative of the top, you get 1 over x. Derivative of the bottom, okay, it's derivative of tangent is secant squared, so derivative of cotangent is negative cosecant squared. And then you need to apply the chain rule because the input was pi times x over 2. So take the derivative of the inner function, get pi halves out front with the negative as well. Don't forget the negative. And now I think we can just take the limit directly. Look, if you plug in 1, you get 1 on top. If you plug in a 1 down here, you get the cosecant of pi halves squared. And the cosecant of pi halves is 1. So you square it, you get 1. So times negative pi halves here. And that's equal to, flip and multiply, negative 2 over pi.